Hello, in this lecture, we are going to do multiple expansions, and mostly it has to do with you can take this lecture as an extension to Legendre's polynomial only. And however, we are going to see much physics in this lecture. So we were all doing Legendre's polynomial for a while now, and it is the right time that we should start with some physical implications for the same. And mostly it has to do with physical interpretations of generating function. So we've studied generating function um, for the Legendre's polynomial, and in this particular lecture, we're going to see how it is um, sort of, we can say, quite helpful when it comes to your electrostatics part. Okay, so let us begin with that. It would be slightly a lecture which has some sort of physical interpretation. So actually, it was getting quite. I should not say boring, but at least because uh, we really need a motivation as to go ahead and so that we can go ahead in the like Legendre's polynomial. Okay, so as a matter of application, I'm doing it, and probably the same, almost similar pattern I'm going to repeat in electrostatics also. But today, let us focus on Legendre's polynomial, Legendre's polynomials, and mostly it has to do with applications, like some of the applications, and I'll discuss them in all the more detail as I go along doing electrostatics. But there I would take a generalized approach. So it is better to see things like it would be a warm-up session for the multipole expansion. Okay, so we've already studied that the generating function. So the generating function for the Legendre's polynomial, for the Legendre's polynomial uh, is given by, so generating function for Legendre's polynomial is given by, let us say it is given by g x comma t. It was like in previous lecture we've written problem where it was just given a reverse one, but koi baat nahi. It is like 1 minus 2xt plus t square. Okay, so this is how it is given. Okay, so this is how it is given. And one would see that whenever you have a potential expression, whenever we want to express a potential uh, for inverse square law forces, we know that the potential is given by kq upon capital R. So small r, kq upon small r. So this is how we write the potential. So we write the potential for any conservative force in the form of kq upon r, right? So this is what we are going to do today. And taking a very simple case at first, let us first develop. Let us first develop the potential for. So this is like you can take it as a warm-up for multipole expansion that we're going to do in electrostatics. So let us develop potential for a charge. Let's say placed at some point, let's say 0, 0, a at a distance r, where r is less than a, where r is less than a. Now we have to find the potential due to a charge placed at 0, 0, a. So let us take this z-axis here only so that it will be easy to visualize. So let us take this z-axis here only. So this is my, let's say, z-axis, and my charge is placed here. So this is 0, 0, a. And we want to find at any such place the potential where r is less than a. We want to find the potential due to this particular let's say charge, like I'll write it here, at any place whose distance is less than a. So let us say let's say this is your r. So let me write this is my r, and let us say this is my r, and let's say this distance I already know. This distance I already know. This is given by a, and why not take this time? So if this is theta, then I know that this particular side is given by root over r square plus a square, and then I will write minus 2ar cosine theta. Is that clear? I mean, this you can do using vector law also, and this you can do using your law of cosines also. Is that clear till now? So what will be the potential at this point? So let me write the potential at the point P would be equals to simply K Q upon R. And instead of R, so I should write some R different way. So this is my R. नहीं इसको कुछ और लिख लेते हैं ना, इसको लिख लेते हैं, ठीक है. So KQ upon इसको ऐसे लिख देते हैं. This is my, let's say, point. This is my O. Let's say this is my point Q. So KQ upon capital PQ. And what will be capital PQ? This will be KQ divided by root over R square plus A square minus 2AR cosine theta. Is that clear? I mean, this is clear to you. And we already know that we want to find potential at any point where R is less than A. So instead of taking R common, here we'll take A common. So let us take A common, because if I take A common, then R by A would be less than 1. Okay, so R by A would be less than 1. So I'll simply take A common out. So I'll take KQ upon A, and this will become 1 upon 1 plus R upon A, and then you have minus 2R upon A, and then you have cos of theta, and then you have minus half, sorry, you have minus half. Is that clear? So if I want to write my potential at any point P such that this point is at a distance where R is less than A, then what will happen? So I'll write it as K Q upon A, and then this will be 1 plus R upon A, and this is, sorry, I think this is square somewhere forgotten. So this is R upon A, and this is minus R upon A, and this is cosine theta, and this is minus R. So this particular expression, you know, forms the generating function for the Legendre's polynomial, and I can equally write it in this form. So I'll write VP is simply, and if there is no such medium thing, so this will be 4 pi epsilon naught A, and then I will simply write summation n equal to 0 to infinity. So this will be this will come here. So R upon A raised to power n would obviously come in, and this will be P in cosine theta. Is that clear? So this is how you're going to write the potential due to a single charge placed at a distance distance A from the origin. And why I have selected Q? Because like why I have selected z-axis only, because usually with reference to z-axis only we take some angles, right? So that is why this is the reason. There is no other way out. There is no other reasons to it. Is that clear?
Yes.
Okay. Now let us complicate a little bit situation, and let us see if we take electric dipole. So I hope थोड़ा सा सबको आता है electric dipole, मतलब standard 12 से उसी concept को उठाते हैं. So let us take the case of electric dipole, and the same topic we are going to study in under the heading called as multipole expansions. Okay. So let us see. एक बार इसको check करते हैं. So if this is the case, so electric dipole में क्या होता है? You know that there are two charges in the case of electric dipole. Okay, so there are two charges. और अच्छा एक काम करते हैं. Let us also try to find, एक काम करते रुक जाओ. Electric dipole से पहले यही केस को वापस से डिस्कस करें, जिससे कि तुम it will be an exhaustive discussion. So एक और काम करते हैं. Let us try to figure out a formula. Let us try to figure out a formula where R is greater than A. Let us try to figure out the formula for the potential for the case R greater than A. So now if your R is greater than A, and so for example, ये हो गया तुम्हारा axis. Let us say this is your z-axis, and so according to right-handed coordinate system, I know that I, J, K, and so K cross I should give me J, or I cross J should give me K. So if you want to find K cross I, so K cross I, so K cross I would give you J, and K cross J would give you I. So if I take K cross J, it will give me I cap. So this is I cap. So okay, जो भी है मतलब I'll have to see कि इसको minus लिखना पड़ेगा, क्योंकि I know that your K cross I is given by J cap. So if I take this as K cap, and if I take this as let's say I cap, so J cap would go, if you use the right-handed coordinate system, place your hand towards z-axis and swirl it over I cap. So your J cap would go मतलब नीचे की तरफ. So अगर यहाँ x है, then this will be your y. This will be your -y. However, they do not matter. Just उनको याद आया, so that एक काम कर सकते हैं, या फिर k क्रॉस i j होता, तो यहाँ i ले लेते हैं, यहाँ मतलब यहाँ x ले लेते हैं, तो अपने आप यहाँ पर y हो जाएगा। इज दैट क्लियर? ये चीज समझ पा रही है मैं क्या बोले जा रहा हूँ देर से? क्या बोलते हैं उसको, तो राइट हैंड रूल। सो यू
Yes, sir.
टेक, है ना, टेक, जिससे कि मतलब ये मैं इसलिए बोल रहा हूँ बिकॉज एट टाइम्स व्हेन वी टीच फिजिक्स स्टूडेंट्स फॉर 11th एंड 12th, बिकॉज उनके लिए ये सब बहुत इंपॉर्टेंट होता है, उनके लिए क्या हमारे लिए भी इंपॉर्टेंट है, पर वो इसमें कंफ्यूज हो जाते हैं ज्यादातर। ठीक है, सो यू शुड रिमेंबर दैट आल्सो, बिकॉज एनी डे विल बी टीचर्स समवेयर हियर और देयर, कोई ना कोई लेवल पे तो पढ़ा ही रहेंगे। आफ्टर ऑल एक एमएससी की तो विल बी डूइंग सम सॉर्ट ऑफ टीचिंग। सो okay, so this is how it is, and let us take it at some distance far away. So ये हो गया तुम्हारा r, और इसको मान लेते थीटा, एंड दिस विल बी देन, इसको लिख देता हूँ मैं रूट ओवर, जैसे कि सिंबल्स का नाटक है, a स्क्वायर प्लस r स्क्वायर माइनस 2ar कोसाइन थीटा। ओके, ओके, इज दैट क्लियर? सो अगर इसको अपन लेके चले, सो देन व्हाट विल हैपन, नाउ नाउ पोटेंशियल, इसी को लिख देता है एट पॉइंट p due to this charge q placed at 0 comma 0 comma a, because now here you can see that your a is greater than, sorry, now you can see that your r is greater than a. So instead of taking r common, now you should take a, instead of taking a common, now you should take r common. So now r, sorry, a by r, I'll write a by r is less than 1 now in this case. In this case, a by r will be. So now, if you want to express your potential, it will be equivalent to writing q upon 4 pi epsilon naught a, and then you can write summation. I think it would be a upon r raised to power n Tn cos theta. Is that clear? So this is the potential at a distance. What should I say? At a distance r from the origin, uh, due to the charge kept at point 0 comma 0 comma a. Is that clear or not clear?
Yes, sir.
ये सब समझ में आया नहीं है? बस सिंपल, मतलब इंस्टेड ऑफ टेकिंग आर कॉमन आउट, इस बार मैंने ए कॉमन आउट लिया। इज दैट क्लियर? यहाँ तक तो कोई दिक्कत नहीं आ रही ना अभी?
नहीं सर, नीचे सर ए दोनों में है ना?
दोनों में ए क्यों है बेटा?
वो आपने लिखा है ना के क्यू बाय 4 बाय 3।
अच्छा, सॉरी सॉरी, इसमें आर है, आर है, इसमें तो आर कॉमन लेके दो, सॉरी। सो क्यू अपॉन 4 पाई एप्सिलॉन नॉट आर आएगा, और ए अपॉन आर की पावर है पी एन कॉस थीटा। ठीक है, बस अंतर ये रहेगा, यहाँ पे आर अपॉन ए की पावर एन रहेगा, और यहाँ ए आएगा, यहाँ पर आर आएगा, और यहाँ ए अपॉन आर की पावर एन। इज दैट क्लियर?
यस।
ओके, so let us go further, and let us see if we are supplied with some dipole case. So now we'll take the case of dipole. So in any case, one of the things that you can see from here, that at a very far away distance, far away distance समझ लो, जब बहुत distance large हो तब क्या होगा? तो यहाँ मैं लिख देता हूँ at very far away distances, far away distances, or you can say for the asymptotic behavior. This is at times referred to as asymptotic behavior. That is for large R. Asymptotic behavior. The leading term, and at times when you do not have any sort of poles because you're talking of single charge, so at times this is sometimes referred to as monopole. Okay, so the leading term in the potential of monopole, in the potential of monopole, is what? कुछ सोच के जवाब दो। यहाँ देखो, यहाँ पे फर्स्ट टर्म लोगे तो जीरो, ए बाय आर की पावर जीरो, और इसके बाद एक और टर्म आएगा ए अपॉन आर की पावर वन, एंड देन पी वन कॉस थीटा। बट यू नो एज आर टेंड्स टू इन्फिनिटी, जो लीडिंग टर्म है, मतलब जो फर्स्ट टर्म है, दैट विल ओनली सर्वाइव। सो आई विल राइट फॉर मोनोपोल द पोटेंशियल, the leading term is 1 over r, so I'll write directly proportional to 1 over r. Is that clear or not clear?
यस।
अगर एक्सपैंड करोगे तो यू द लीडिंग टर्म मतलब जिस पे सारा डिपेंडेंस है, बिकॉज जैसे जैसे आर बढ़ाओगे द हायर टर्म्स विल गो टू जीरो। सो यू जस्ट नीड, because in physics also most of the times you'll be concerned with what is a leading term. However, the like problems फॉर एग्जाम्पल कोई प्रैक्टिकल लिमिटेशंस हैं, कोई प्रैक्टिकल प्रॉब्लम्स है, वहां पे हम हो सकता है इससे ज्यादा भी ले लें, मतलब डिपेंड्स ऑन द फिजिकल सिनेरियो एज सच, बट ओवरऑल द लीडिंग टर्म behavior would be 1 over r. Now let us take the case of electric dipole.
Right.
Okay, so now let us take the case of electric dipole. So what should I write? So electric dipole, how will I make? And let us like now I'm only taking the discussion for r greater than a. Why I'm taking for r greater than a? As I've told you that in physics, most of the times would be concerned with finding the asymptotic behavior, right? So I'm moreover concerned with the discussion for r greater than a. So now I'm going to reserve my discussion for r greater than a. So let us first take the case of electric dipole, and let us see how the leading term would behave as r is going towards infinity, or you could say as r is becoming large and large whatsoever. So let us take one of the charges at a, that is 0 comma 0 comma a, and one of the charges at minus a. Okay, so this is symmetric condition where your charges, and let's say this charge is q and let's say this charge is minus q, and we want to find potential at any far away point, and let us say this is located from the center at a distance smaller. Okay, and then this will be 1 and this will be another 1, like because of this charge and this charge we have to totally write the like जो भी लिखना है हमको. So this will be like theta, और एक काम करते हैं थोड़ी देर के लिए इसको r1 लिख लेते हैं, इसको r2 लिख लेते हैं. Okay, कोई इश्यूज नहीं. This will be r1 and this will be r2. ठीक है. So if this is r1 and this is r2 and this is your point P, okay, and one needs to find what is the potential at point P. How should I go about it? So first thing that so for example, now if this is your theta, if this is your theta, and what should I write? इसको ऐसे करते हैं एक बार को. This is your theta. So I'll write one of the like एक काम करते हैं, यहाँ से पकड़ने की कोशिश करते हैं. Okay. Okay. So what will be the potential at point P? The potential at point P can be written as K Q upon 1 upon R1. इस पे काम करते हैं R1, ये 1 upon R2, sorry, 1 upon R2 लिखा है यहाँ पे, minus 1 upon R1. Is that clear? So now this will be 1 upon R2 minus 1 upon R1. What will be R2? So what will be R2? R2 will be equals to root over, this will be R square, and this will be plus, I think this is A from here to here. So this is A here. So R square plus A square, and then you have minus 2AR cosine theta. And if you see in this triangle, so this is your R1, this is your R1, and if this is theta, this angle would be simply pi minus theta, if you see. So now your R1 would be equals to root over, I think this would be R square, and then there would be A square, and then there would be A minus 2A minus R cos of pi minus theta. Okay, so this would be root. So this is how it will be. So if I write my R1 and R2 in more articulate manner, my R1 would then be equals to root over R square plus A square plus 2AR cosine theta, because cos pi minus theta is minus cos theta. Is that clear? So R square plus A square plus 2AR cos theta. This is how it is going to be. Okay, now understand one more thing, that what will be the potential at point P. So I'll write all these things here. So now, as I've told you, that we are only focusing on the case R greater than A. We are only focusing on the case R greater than A. So what it would be? It would be equals to writing K Q upon R, and then this will be 1. What is R2? This is 1 minus 2A upon R, and then you have this cosine theta, and then you have this A square upon R square raised to power minus 1 by 2. And then you have again minus 1, I think that would be plus 2a over r. This will be cosine theta, and then there would be a square by r square, and then there would be again minus half. Okay, so this is your potential at point P, and I'll write it here. So potential at point P would be simply Q upon 4 pi epsilon naught r, and then this particular expression, as you can see, is nothing but it is equal to summation n equal to 0 to infinite, and I would write it in the manner Pn cos theta, and then I will write I've written a, so I'll write a upon r raised to power n. Okay, and the other one, like ये समझ में आ गया ना, इसको कुछ है नहीं बेटा, लाइक ये जो R2 है,
Yes.
ये एंगल देखो थीटा है, तो यहाँ मैंने लिखा r स्क्वायर प्लस a स्क्वायर माइनस 2ar cos थीटा, और ये R1 देखो ध्यान से, इसके सामने वाला एंगल देखो, तो जो लॉ ऑफ कोसाइंस होता है ना, मैं लिख देता हूँ, देखो लॉ ऑफ कोसाइंस, इफ यू फॉरगॉट I'll write it here. However, there are 2 students who have approached me for their JEE entrances. So probably I'll teach them all these things, trigonometry and everything. So if this is A, this is B, and this is C, then I'll write C square is equal to A square plus B square minus 2AB cos theta. This is the law of cosine. Okay, so this is law of cosine. So accordingly, I've written this. Okay.
Sir,
So
आवाज ब्रेक हो रही है.
अच्छा, okay. अभी आ रही है आवाज?
हाँ जी सर.
अनस्टेबल हो जाता है बीच में नेटवर्क. सो आई थिंक दिस इज इट. अभी सेकंड वाले में हम क्या लिखेंगे? समेशन n equal to 0 to infinite, and now I'll write Pn cosine theta, and instead of a upon r, I'll write minus, sorry, I will simply write minus a upon r की power n, because यहाँ पे 2ar है ना, तो इसको लिखो minus 2a. So instead of a upon r, I'll get minus a upon r की power. Is that clear? बस कुछ नहीं किया है, बस 2ar है ना बेटा. r1 में आपने क्या किया? cos pi minus theta लिखा होगा. सी R1 के सामने वाला एंगल क्या? cos दिस पाई माइनस थीटा. cos पाई माइनस थीटा क्या होता है? नेगेटिव. तो ये माइनस 2ar वाला स्ट्रक्चर एज इट इज इंटैक्ट मेंटेन करके चलो. इस माइनस को यहाँ लगा दो, माइनस a क्या है? जस्ट गिव मी जस्ट गिव मी अ मिनट. Is that audible now? Actually, power has gone.
Yes sir.
Okay, just give me a minute. एक मिनट तो मुझे. Am I audible or not audible?
Yes sir.
Okay, so actually power was done now, so I had to. Okay, so what we were doing the case of the electric dipole. Okay, so just give me a minute. ठीक है, अब थोड़ा ध्यान से देखते हैं इसको. What you can see that the constant term, that is n equal to 0, they would cancel out, because n equal to 0 would correspond to 1 here and 1 here also. 1 minus 1 would go 0. What are the terms which will survive? So you can clearly see only odd terms would survive, because see, if odd is here, then this negative will come out, negative negative will become positive. And if n is even, then both of these terms will go to 0. So I'll write only odd terms will survive. Is that clear?
Yes, sir.
And odd terms in n would survive. And if I want to write the potential P, it will be Q upon 4 pi epsilon naught R, and it will be equivalent to writing summation. I'll write some different symbol. Yeah, एक काम करते लिख लेते same symbol. N equal to 0 to infinity. This will be P 2n plus 1 cosine theta, and there would be 2 also, and there will be A upon R की power 2n plus 1. Is that clear? Odd terms ही रह जाएंगे और ये दो गुना हो जाएंगे. Because see, जब n की जगह आप 1 लेते हो, this would be 2pn cos theta A upon R. मतलब यहाँ समझ पा रहे हो? मतलब अगर n odd है तो negative will come out, negative negative will become positive. This will become 2 times. Is that clear or not
Yes,
clear?
sir. Yes, sir. Yes.
Okay. So in any case, understand the potential P can be expressed as Q upon 4 pi epsilon naught R. And then you have, I'll write 2 in fact here. But I should write 2Q here. So एक वहाँ पे एक pattern बन जाएगा 4 pi epsilon naught R. And then you have this summation A upon R की power 2n plus 1. And then I will write P 2n plus 1 cosine theta. Is that clear? So this is how you can write your potential, like electric potential due to dipole at any far away distance greater than A. Is that clear?
Yes, sir.
Okay. In this configuration, I know from standard 12th, you know, is called as your potential. It is called as electric dipole. And you know that the electric dipole moment is given by the charge times the magnitude of distance between them. So magnitude of charge into distance between them. Is that clear? I mean, ये हम बचपन से पढ़ते आ रहे हैं. This is called as your dipole moment. This is called as your
Yes, sir.
dipole moment. Okay, so derivations अलग होंगे थोड़ी सी, बाकी चीजें वहीं की वहीं है. ठीक है. So स्टैंडर्ड 12 के बच्चे को पढ़ाओगे तो उसको ये सब नहीं बताना है. मतलब ये सब बताया वो फिजिक्स वहीं उसी दिन छोड़ देगा, अगले दिन आएगा भी नहीं क्लास में. पर उसको
Yes.
उसको बिल्कुल बेसिक तरीके से ही के क्यू अपॉन आर करके करना है. उसको नहीं बताना है कि जनरलाइज्ड रिजल्ट भी लिख सकते हैं. उसको तो बस यही बोलना है कि आर ग्रेटर देन ए के लिए किस तरीके से आपका डायपोल बिहेव करेगा. However, we know that okay, it will depend upon theta as well. Okay, it will depend upon theta as well, and not only just theta, at various powers of cos theta. So that result you also develop in standard 12 now. अगर हम लोग कहें कि what would be the leading term? So if I ask you what is the leading term, so one can really see that the leading term for the dipole would be inversely proportional to r square. Because you see, अगर यहाँ से r की power 1 वाला term लिया हमने, एक r already है, so potential, the leading term for the what should I say, dipole, potential due to a dipole would be 1 over r. Is that clear?
Yes.
और इसी चीज को थोड़ा ध्यान से लिखें, so हमको क्या लिख सकते हैं? We can write it in this fashion. So Vp, I will write, if I take q and like if I take this leading term only, so this will be like q 2q upon 4 pi epsilon naught r. Just take the leading term, that is a upon r, and then you have this cosine theta. So simply I will write it as Vp would be written as, and Vp would be written as simply some small p. या इसके लिए कुछ और symbol देख लेते हैं. So let us not write this as p. Let us write it as mu. So if mu is your dipole moment, so I'll write mu upon 4 pi epsilon naught r square, and then you have this cosine theta. So this is what you you might have developed in your standard 12th also. Okay, this is what you have developed in standard 12th, because there also the same things are there. Instead of law of cosine, probably you may say that this is the vectorial relation. So resultant vector, like teachers write in your standard 12th, because that is what they can expose their children to. With given limited resources of mathematics people have at standard 12th, this is what is a limited thing that the standard 12 teacher can do, and he's right in his own capacity. But when we come to MSc, we'll go for this kind of generalized expression for the dipole, for the potential due to a dipole. Is that clear? And subsequently, I'm not going to write it. I'm just going to, I'm not going to derive it. I'm just going to give you a direction that if one needs to find what the electric field electric field would be dependent upon r and theta, and I can write it will be r cap plus e theta cap, and this can be readily found by just doing the grad of v. You can find the electric field, and I'll just write what electric field would be. So electric field, the radial component would be minus del upon del r of v, and minus 1 upon r del by del theta of v would give you electric field theta component, and this will give you electric field's radial component, and you'll get 4aq, and you can write cosine theta, and then you can write 4 pi epsilon naught r cube. This is your radial component, and this is your theta component. This is something that I'm leaving for you as an exercise. You can do it at your own will at any time. So I mean, this is very easy. So is that clear? Okay, so this r cube is because of this. Don't worry.
Yes,
this r cube is because of this. So I think this is,
yes.
And if one asks you what would the phi component, because this is three-dimensional case, this would be 0. There would be no as such phi component. Okay, is that clear?
Yes, sir.
Okay. So now let us move to the case if there is a time limit. So what I can do is, let us take case of electric quadrupole, and let us take a linear quadrupole. I'm not taking it in it, because in general, when you study, when we study things in physics, we'll see that this quadrupole moment is going to come out as a tensor. So right now, because I have not taught you tensor, and probably it will take me time to reach till tensor. So just take the case of a simple one that we do in your standard, that one does in standard 12th only, linear quadrupole moment.
सर 5 0 क्यों किया उसमें ऊपर?
Just to tell कि ये 3 dimension, अगर 3 dimension, because see I have taken 3 dimensions ना, मतलब अगर ये मतलब z axis के along है, तो हम देख पा रहे हैं कि there is no such phi component. So if someone asks you what is the e phi component, so just tell him कि इसमें कोई component ही नहीं है e phi का. So just write e phi is 0, because if potential does not depend on phi, because this is 3-dimensional case in general. This is 3-dimensional case in general. Okay, so let us take the case of linear quadrupole. Linear quadrupole is an easier case where you have a set of 2 dipoles. Okay, where you have a set of 2 dipoles placed on the line. So instead of placing 2 dipoles, what we actually do, at the center we'll take a charge minus 2q. So you can think of it as minus q and minus q. At some distance you can keep q, and at some distance you can keep q. This is what teachers teach you at standard 12, right? Or whichever level you might have studied it. Okay, so this is 0, 0, minus a, and this is at 0, 0, a. And one needs to find what is the potential at a far away distance r. What is the potential at a far away distance r? And we need, again, because all these things we are going to use directly when we are going to do multipole expansion. So that is why I'm teaching you, and this will at least instigate some sort of मतलब कुछ तो boringness कम होगी, नहीं तो बहुत ही boring हो जाएगा. So if this is the case, and we want to find our r at our potential at any r, then again this is the same, this is again the same. और ये ऐसा समझो जैसे ये 2 -2q रखा हुआ है ना, इसको माइनस क्यू समझ लो. एक माइनस क्यू ये रखा है और एक माइनस क्यू यहाँ रखा है. ऐसा समझ के देखो कि these are 2 dipoles. Is that clear?
Yes, sir.
है ना, इसी तरीके से कराते हैं ना बचपन में. सो एट लेट्स से दिस इज योर आर. सो इसको अगर आर वेक्टर लिख लेते हैं, बात बच्ची खत्म. सो दिस विल बी सिंपली, इसको ऐसे लिख देते हैं, दिस विल बी आर वेक्टर. सो अगर ये है मेरा, इसको लिख लेते ए के कैप, या इसको लिख देते ए के कैप, इसको लिख लेते आर. सो ये क्या हो जाएगा, सिंपली दिस विल बी आर वेक्टर, एंड दिस आई कैन राइट माइनस ऑफ a k cap, right? So this is our एक गलत तरीका से इधर कर लेते हैं. So according to triangle laws of addition, if these two are in the same direction, then the resultant is in the opposite direction, right? So if this is your r vector, if this is your r vector in this direction क्या होगी सोचें. So this plus this should give you r. देर है a cap plus r vector minus a k cap. मैं क्या वो बार वो थीटा वगैरह यूज नहीं करना चाह रहा, log of sin. एक बार ऐसे करके देखते हैं, r cap r vector minus a k cap. Is that clear? And this will be r vector plus a k cap. या फिर चलो वैसे भी कर सकते हैं, ऐसा कोई बड़ी बात नहीं. Is that clear or not? कहाँ चले थे, है ना? Is that clear? मतलब just for the sake, बाकी ठीक है, of cosine भी इसको तो big deal नहीं है. So let us write potential at point P. So let's say this is your point P. Let us write potential at point P. So potential at point P will be kq upon epsilon naught. So kq upon epsilon naught, and then you have this distance would be what it will be equals to, writing 1 upon r vector plus ak cap का mod. This distance will be minus 2 upon r vector का mod, because this will be minus 2 kq upon r simply. So I've written minus 2 kq upon r only, and the last one would be 1 upon r vector minus ak cap का modulus. Is that clear? And I know that modulus is modular, like what is this resultant vector? I know this would be equal to q upon 4 pi epsilon naught, and this will be 1 upon root over, this will be r square, and this will be a square minus 2ar cos theta. This will be again, I'll write simply minus 2 upon r, and this will be, I think, 1 upon root over r square plus a square plus 2ar cosine. Is that clear?
Yes, sir.
Okay. So what next? So what I'll do, I'll simply try to expand all these things, right? I'll try to expand all these things in Legendre's polynomial. So this is how handy these Legendre polynomials are. So 4 pi epsilon naught r, and now we are quite acquainted. So I'll simply write this as n equal to 0 to infinity, and this will be a upon r raised to power n. Then I'll write Pn cosine theta, and then I will write minus 2 upon r, and then plus summation, again n equal to 0 to infinity. I'll write minus a upon r raised to power n and Pn cos theta. Is that clear now? Now understand, here there is a plus sign, not a negative sign. So क्या क्या टर्म बचेंगे? देखो, फर्स्ट अंडरस्टैंड, जो एक टर्म बचेगा, कहाँ गया वो, जो
Even के लिए.
एक, हाँ जी, sorry. So
Even
only
even terms
only
के
even
लिए.
terms, only even terms would exist. Okay, only even terms would exist. और जैसे हम लोगों ने मान लेते हैं कि n equal to 0 भी ले लिया, अगर n equal to 0 लोगे तो सिंपली क्या आएगा? आई थिंक कुछ गलती की है मैंने करने में, या 2 upon r नहीं आना चाहिए. अगर मैंने r कॉमन ले लिया तो इसको हटा ही देता. सो अगर n equal to 0 लोगे तो n equal to 0 पे ये वैसे 0 आ जाएगा, समझो. n equal to 0 पे 0 आ जाएगा, बिकॉज n equal to 0 पे ये 1 हो जाएगा, ये 1 हो जाएगा, 1 plus 1 minus 2 खत्म.
Yes, sir.
इवन टर्म आएंगे,
Yes.
लेकिन नॉन जीरो इवन टर्म्स आएंगे. इज दैट क्लियर?
Right.
So this, I'll write, this will comprise of नॉन जीरो इवन टर्म्स, क्योंकि वही वाली प्रॉब्लम हो जाएगी जो पहले हो चुकी थी एक बार अपन से. क्योंकि अगर इसमें से एक जीरो वाला टर्म रहेगा, देयर वुड बी अ लीडिंग टर्म 1 ओवर r. सो गलती हो जाएगी. सो इट विल ओनली हैव नॉन जीरो इवन टर्म्स. सो एक काम करते हैं, bp I'll write q upon 4 pi epsilon naught r, and then I will write simply n equal to 0 to infinity. I'll write a upon r की power 2n, and then I will write p2n cos theta. Is that clear? इस तरीके से हमारा
Yes.
अब हमारा डायपोल मोमेंट कैन बी डायपोल मोमेंट इस तरीके से वी कैन एक्सप्रेस आवर क्वाड्रुपोल potential due to a quadrupole at a distance, relative distance r, which is very greater than the distance between the two, like what you can say charges, or you can say here the dipoles, because a represents the distance between the concerning dipoles. Is that clear? So what you should understand from here is again the leading term. So in the case of quadrupole, the leading term is proportional to 1 over r cube. The first thing that needs to be seen is this. Is that clear? Okay, and I think I've forgotten
Yes.
2 somewhere, so I'll write 2 here, because ये दो गुना भी तो होंगे. Is that clear?
Yes.
So this is 2q upon 4 pi epsilon naught r summation p2n cos theta, and then you have this a upon r की power 2. Similarly, you can express, we can find linear quadrupole. We can find the potential due to a linear quadrupole, and for linear quadrupole we need actually this kind of configuration. So this kind of configuration is called as a linear quadrupole configuration. So I'm writing it here. We'll do it tomorrow. This is minus 2q. I'll write q here, and again I'll write minus 2q here, and this is at. So this is your linear quadrupole. So this is how you express your linear quadrupole arrangement. Sorry, quadrupole बोल रहा हूँ, linear octupole arrangement. So this is your linear octupole arrangement that we are going to see tomorrow. I'm just going to leave it here because I don't have much time, but I'll write at least what is essential. this is at A, this is at distance to A, this is at 0, 0, 0, this is your origin, then this is at distance minus A, and this is at distance minus 2A. Okay, is that clear?
Yes, sir.
Okay, so this is a linear octupole arrangement, and we are going to see how does the potential varies there. How does the potential varies there, and this is how like we're going to progress further in the theory. Okay, so I hope you might have got much of it. इसमें कुछ ऐसा तो नहीं जो नहीं समझ में आया?
नहीं सर, क्लियर है.
चलो जी, so हम कल मिलते हैं. And sooner we're going to start with, again, I told you, I promised you in this week that we'll start with linear vector space. We'll start anyhow. एक बार इसको खत्म हो ही जाने देते हैं, है ना? चलो,
जी सर.
ओके ओके ओके,
थैंक यू सर.
बाय बाय.